this is Angelica Madsen's test 3 correction video. So the first problem that I got wrong was problem number 3. It says a skateboarder travels down a curved path ending up at the lower height than when he started. Which statement is correct about the work on the skateboarder? So basically what I put as the answer is E, although you can see I was not certain if it was E or C when taking the test, but I went with E, and what my reasoning behind that is because when you look at the skateboarder going down the track, I was thinking about how, yes, he's going downhill, but I was thinking more in the X direction more than the Y direction as the work. And I was thinking, I wrote down here, work is in the direction horizontal but not vertical. So that's why I was thinking that the normal force and the force of gravity both do 0 work. But when you think about the total work done on the skateboarder, he is traveling down the hill, and so gravity is doing a positive work because it is forcing him to go down. And the normal force stays the same the whole time because he doesn't actually get pressed down on the ground harder, he just travels down. So that is why that is why C is the correct answer. The normal force does 0 work and the force of gravity does positive work. The next problem that I got wrong was problem 4. It says if you slam on the brakes in your car in a panic and skid a certain distance in a straight, level road, if you have been traveling twice as fast, what distance would the car have skidded under identical conditions? I put answer D. I don't even know why I put answer D, but the correct answer is A. It would have skidded 4 times further. And let's see. I wrote in here why. That's because this is the equation. The velocity is squared. And if you're going 2 times as fast, the 2 will be squared as well. And 2 squared is 4. So it will be going 4 times farther than it would. The next problem that I went over is problem number 6. And it is about an object compressing a spring, and then it is released and travels along a frictionless surface, and then it says the spring, the initial velocity is 26 centimeters per second, and we are trying to find what the spring constant is. So this is all my work that I did. Kind of makes sense, kind of doesn't make sense. Got the wrong answer. How I reworked it out for problem number 6. So we were given the mass and the compression distance and the velocity. The velocity as soon as it left the spring. So I said that the kinetic energy is transformed from the energy of the spring since it is frictionless, so kinetic energy is equal to energy, and the kinetic energy equation is this, and the spring energy is this. So you set them equal to each other because, as I said before, the energy is transformed, and so then you're able to solve for k. Both of the halves will cancel out, so I just rewrote it without the halves. And you solve for the constant, which is this equation, and then you were able to just plug in what we were given up here, and you get the 3.4 as your answer. Now the next problem that I got wrong was problem number 7. Let's see. Yeah, problem number 7. It says it gives you force, and it acts in the X direction. How much work is done by the force? in moving an object along x from 1.1 meters to 3.3 meters. And as you can see, force is not constant, it is changing, so you have to integrate from the initial position to the final position of force. And I did that all correct, and this is what you get. I did that all correct when I typed it into the calculator. However, I did type it in wrong, so I did get the wrong answer. But yes, the correct answer is the 156.74. All I did was type it into the calculator again, and I got the correct answer. So the next one that I want to go over is question number 8. This one is about a basketball thrown, a baseball is thrown from the pitcher and hit by a bat. And we're trying to find what the magnitude of the impulse exerted on the ball by the bat is. Now, I kind of drew a little diagram, so it's initially going 40 meters per second towards the bat, and then after it is hit, it is going 80 meters per second, and the ball is 0.16 kilograms. So, what I did for that one, so here this is, here is all the information we were given, written again right here, and then, so j of x is a given equation. It equals these, and so pretty much you just plug it in. What I did wrong is I didn't account for the fact that when it is returning from the bat to the pitcher, its velocity is going to be negative. So instead of positive, I just had to make sure that was negative, and then I do the same equation that I did on the test, and I get it right, and that is negative 19.2. So that's the only thing I did wrong, is I forgot that negative. Now the next problem number 9, it's about the exploding coconut that is originally going 3 meters per second in the east direction. A firecracker blows the coconut up. 2 pieces of equal mass fly south and west perpendicular to each other at 20 meters per second. The third piece has twice the mass as the other 2. We're trying to figure out what the speed of the third piece is. So I kind of drew a little diagram here. So these are the 2 perpendicular pieces, and then because we have equal and opposite forces, these 2 pieces are going this direction, so our third piece will be going 45 degrees above east. So, this is kind of what I did, a bunch of random work. Wasn't exactly sure what I was supposed to do on this one, but I kind of wrote down some formulas. Now how I really solved it, let me get there. So I redrew the diagram, and we know this is the equation to use. So what I did is I kind of plugged everything in, and we know that the masses will eventually cancel, but we do know that mass of piece 3 was 2 times, so down here I do put a 2m in there because it is twice the mass of m1. And then, so y is going to be our initial speed, and that was 3 meters per second. So y is equal to m initial, v initial, y, all this stuff. And then you just plug it in, and so the y's cancel, is what I'm saying here. So these are our velocities, our initial velocity, and then you plug everything in that we know, and we do sine 90 as that. That is because that is because when that is the downward, that's the east direction, the y magnitude, and then, but that's 1, so it didn't really matter, and it's negative because it is going downward. And then sine 45 is what we used for the direction of the third piece, because it is 45 degrees above east, and we're trying to find the hypotenuse. So that's where the sine 45 came from. And then, so we're solving for V3 in the equation, and we get 16.26 meters per second because it is velocity. Alright, and then next problem we're going over is going to be problem number 10. And this one is about a 5 kilogram ball hanging from a string and is struck by a stone. And we're pretty much just going to find out what is the maximum height that the ball reaches. And so this is what I did. I kind of had the right idea, kind of didn't, just like every other problem. Plugged in what I knew to lots of different things. So how you actually do it is pretty simple. So same as the very last problem, is you get this initial and final equation. So the initial mass is 5, and the velocity, the initial velocity is 0 because it is at rest. The second mass is 1.5 kilograms, and the velocity of the stone is 12 meters per second. And then our final velocities and masses, it's still gonna, the masses are both gonna be the same as well this time because they just hit one another. We don't know our final velocity of object 1, but we do know our final velocity of object 2 was 8.5. Now you just solve the equation for our velocity, and this is the equation you get, and then you plug everything in and you get the 6.515 meters per second as the velocity of the ball. Now, the next problem will be problem number 11. Problem number 11 is about you working on a row machine. So this one's pretty straightforward. I'm not going to read the problem out, but pretty much you're given the distance, the time, and the amount of work done to the system, and we're trying to figure out what the force is. It's a lot simpler than I thought. I didn't get there though. So what you do is, this is the equation for work, for power, not work. And we're given all of these things, so pretty much you just rearrange the equation to find the force, and you plug everything in, and you get the 102.5 newtons. Alright, and for the very last problem, problem number 12, it is about a block sliding down a hill, and it hits a spring, and pretty much we're just trying to figure out the height of this based on the compression and everything of the spring. So, let's see where I wrote down the problem. Oh. Okay. So we know that the initial energy is going to be equal to the final energy because of conservation. EI, so the initial energy is going to be of the spring, and the final is going to be this is gravity and this one's the spring, but we know that they're going to be about the same, so we can set them equal to each other and then solve for the height. And we basically plug everything in because we have everything, and we find the height, and I got this. And then for to find the distance up the hill, that is our hypotenuse, and we know that sine is equal to opposite over hypotenuse, and we have the height, and we have the angle, so we're able to do sine of 18 is equal to height over, I just put question mark and went with it as my constant instead of like x or something, so h over question mark. And then we're able to solve for the hypotenuse, which is question mark, and I got 1.705 meters as my distance. Alright.